In the journey to solve quadratics, we have discovered that factoring is not always possible for every quadratic. So today we're going to look at another technique called completing the square, which uses properties of algebra to create a perfect square, to which we can then apply the square root property. So beginning with this quadratic, our first step is to add the 9 to each side, creating then an x squared plus 16x plus an unknown amount that will then equal the 9 plus whatever that unknown amount is on the other side. Our dream is to have this be the perfect square, and knowing that that comes from a binomial times a binomial tells us that the same sign has to be applied in order to be written as a square, and furthermore what the sign is driven by the sign in front of the b. So in our case we do know that this is going to be an addition. We know that the first times the first will require that this be the x times the x. And so the question is, what would be the last times the last, which when added to itself then is going to create the b term of 16. We can arrive at that by dividing in half. Since the inner and the outer are added together and they must be identical, I can simply divide the b term by 2, and that will tell me what term must be sitting in this location. Now, if that's an 8 and an 8, I can then use that to arrive at the fact that 8 times 8, or 64, must be the unknown term that makes this quadratic perfect. Now, remembering our algebraic rules, we must then, having added 64 to this side, we must add 64 to the other side. Simplifying and rewriting then, we have x plus 8 quantity squared equals 9 plus 64, or 73. I now am in a position to use the square root property to solve. I can take the square root of each side. The square root of the square is x plus 8 will equal either a positive or a negative square root of 73. So x itself must have the value of, subtracting 8 from each side, negative 8 plus and minus the square root of 73.